All right, here we are, part 3 of 6.1, solving trig equations. Okay, so take notes. 6.1, part 3. Okay, so here we are going to use factoring. Okay, so solving by factoring starts with an F. Okay, so let's just recall how we do that with regular quadratic equations. Suppose you had this 2x squared minus 9x equals 5. Okay, so if you remember how to do this, you had to make sure that it was set equal to 0 before you started factoring. So I'm going to go ahead and subtract 5 on both sides. So I get 2x squared minus 9x minus 5, and I get 0 on the right-hand side. Okay, and then I would go ahead and factor. So 2x times 1x to make 2x squared. And I want negative, so negative 5. So I'm going to need a positive and a negative. And then there's only one way to make 5, and it looks like it's going to be this combination right here. And then we check to make sure we get negative 9x for the middle term. We do that by doing this product on the outside. 2x times negative 5 is negative 10. Combine it with the inside product 1 times x, which is positive 1x. So negative 10 plus 1 is negative 9. Okay, so this is the correct factorization. Once you have the factors, you can set them equal to 0 and solve for x. So we get 2x equals negative 1, divide both sides by 2. So x equals negative 1/2. And then over here, just add 5 to both sides. So x equals 5 is the other answer. Okay, so we're going to be doing this similar process with solving trig equations. So let's go ahead and take a look at this example here. So suppose I need to solve 2 cosine squared t minus 9 cosine t equals 5. And let's put this restriction here. T is between 0 and 2 pi. We're not using a calculator here, I don't think. So, but if we do need to use a calculator, then we would need to make sure we're in radian mode according to this here. Okay. All right. So let me bring this equation down here so we can work with it without losing the original problem. All right. So I need to subtract 5 on both sides. Okay. Set it equal to 0. And then here, I can go ahead and start factoring. So it's going to be 2 cosine t times cosine t to give me 2 cosine squared. And I want negative, so it's going to be 1 positive, 1 negative. There's only one way to make 5, and that's 5 times 1. And this here, negative 10 plus 1 gives me the negative 9 in the middle. So this is the correct factorization. So then I go ahead and, just like the previous example, I take each factor and I set it equal to 0 and solve. So here I'm going to subtract 1 on both sides and then divide by 2. And I get cosine t equals negative 1/2. So let's solve this one first. All right, cosine is negative in this quadrant. So this is quadrant 2. So we need an angle from there and in this quadrant. and we need an angle here. So hopefully you have them memorized. Um, so cosine is 1/2 at 60 degrees. So this here has reference angle pi over 3. So they both have reference angles of pi over 3. So here, t must equal, in the quadrant 2, that's going to be 2 pi over 3. And then in quadrant 3, that one is going to be 4 pi over 3. Okay. So how do I know that? It's because it's it's cut into thirds. So like here's 1/3, 2/3. Over here's 3/3. That's 4/3. So this is pi over 3, 2 pi over 3, 3 pi over 3, which is pi, and 4 pi over 3, 5 pi over 3, and 6 pi over 3, which is 2 pi. Okay. All right. Over here, add 5 to both sides, and we exceed our limit of 1. So here, there's no solution. Okay. Just remember, the largest cosine and sine can be is 1. Okay. All right. Let's try this one. See if you can do this one on your own. Try the factoring. All right, solve 2 cosine squared t plus 3 cosine t equals -1 if our angle is between 0 and 2 pi. Okay. All right, so go ahead and hit the pause button, work it out, and come right back. Okay, so I'm going to write the problem down here. Okay, so I need to set it equal to 0, so I'm going to add 1 to both sides. I get 2 cosine squared t plus 3 cosine t plus 1 equals 0. I'm going to go ahead and factor this. So it looks like 2 cosine times 1 cosine, plus and plus, and it's going to be 1 times 1. And outside I get +2. Inside I get +1. 2 plus 1 is 3. So this is correct. I'm going to take each factor and set it equal to 0 and solve. So I subtract 1 on both sides. And then I divide both sides by 2. And cosine is negative over here and over here. And we just did this. And so this is going to be at 2 pi over 3. And this is going to be at 4 pi over 3. Okay, so t equals 2 pi over 3. That's one answer. And the other one is 4 pi over 3. Okay. Over here, cosine t plus 1 equals 0. So subtract 1 on both sides. We get cosine t equals -1. And we have that one memorized. That is at pi. So those would be your answers from 0 to 2 pi. Okay. All right. Let's do one more. One more where it's not factorable. So we have to use the quadratic formula. Okay. So using quadratic formula. Hopefully you have that memorized. If not, you can just Google it. Okay, so let's take a look at this one. Solve 2 sine squared theta plus 2 sine theta minus 1 equals 0. if theta is between 0 and 2 pi. Okay. So, which means we're going to have to be in radian mode. We're using quadratic formula, so it's not factorable. So we're going to have to use our calculator, and we need to make sure we're in radian mode. Okay, so you can try factoring here. I'll go off to the side, and so because we can't really tell off the bat if it's factorable or not until we actually try it. So if I try factoring this, right, I get 2 sine theta here, sine theta here. One of these has to be positive, the other one has to be negative, and it's just 1 and 1. And no matter how I rearrange this, I'm not going to get this middle term. Okay, so this here, because if you look here right now, I get -2 plus 1. -2 plus 1 is -1. If I try switching things around, I still get the same thing. Okay, even if I put this one negative, this one positive, that just changes the sign. So that here I get 2 minus 1 is positive 1. Okay, I don't get this middle term. So it's not factorable. Once you realize that it's not factorable, then you have to use the quadratic formula. Okay? All right, this one's going to get a little messy, so let's try to keep track of everything. All right, so sine theta equals, so A here is 2, A equals 2, B equals 2, and C equals -1. Okay, so sine theta equals, instead of using x equals -b, we're using sine theta because we're not using x. Okay, so sine theta equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. So I get -2. I'm going to go ahead and work this all out. 4, this is going to become plus, and we get 8 all over 4. -2 plus or minus square root of 12 all over 4. And this isn't actually going to simplify to anything nice. So instead of trying to simplify the square root 12 and like reduce it as much as possible, we're going to end up punching this into the calculator anyway. So I'm just going to stop right there, punch it into the calculator. All right, so I get these two things. Sine theta equals, when I work out the -2 plus square root 12 all over 4, I get one answer. And then when I do -2 minus square root 12 divided by 4, I get another answer. Okay, so I'm going to put them both those answers here. So I get sine theta equals -1.366, and I get the other one, sine theta equals positive 0.366. Okay. All right. So this is what we need to solve. Okay. So now I go ahead and I need to solve for theta. So I'm going to use my calculator. Okay. So I'm going to do my sine inverse of, okay, so this number here, -1.366, that is smaller than -1. So remember, the smallest we can have is -1. The largest we can have is +1. So, so this one, no solution. All right, so let's do this one. Sine inverse of 0.366 equals, this one equals like roughly, here, I'm just going to do this because I'm running out of room down here. So I can't put the full decimal, but 0.375 roughly. Okay. All right. So this here tells me, okay, so first of all, again, I want the theta where the sign is positive. So that's going to be here. We're going to have an answer from quadrant 1 and an answer from quadrant 2. And this tells me, this means the reference angle is 0.375. Okay? All right, so then if I want the quadrant 1 angle, well, that's actually going to be 0.375. Okay, so one of my angles is 0.375. And then if I want the one that goes all the way here, it's going to have to be, so this is my quadrant 1 angle. That one was easy. Quadrant 2 angle, it's going to be pi minus our reference angle, 0.375. So that is going to be 2.7, 2.77. Okay. All right, so those would be our two angles here. It looks like here, let's just go with that and that. Okay, so these would be our two angles. So theta equals 0.37 and theta equals 2.77 radians. Okay, so a little messy there, but hopefully you were able to keep track of how I got these answers. Again, this one, no solution. Here I use sine inverse. And remember, when you use sine inverse, you're really finding the reference angle, and then you can make your changes as needed, depending on the quadrant, the quadrant where you want your angles. Okay, since 0.37 is already in quadrant 1, and we want a quadrant 1 angle, that's one of our angles. Okay, it's a little more interesting when we have it like down here. Okay. Okay, so that is it. If you have any questions about this, make sure you email me or text message me.